Morning, everybody.
Morning.
Today I'm going to talk to you about wireless standards. Just a little bit of general information. Most wireless standards run half duplex over air modulation. Does anybody know what half duplex is? It's where data is sent one way, then the other. It can't be sent at the same time. The radio frequency actually varies based on the country you're in. So an A standard here could be one frequency and it can be different in another country. It all depends on what kind of radio frequency you're in use for different things in that country. They control interference via direct sequence spread spectrum and orthogonal frequency division multiplexing. Basically, it's a way of controlling interference via holding onto the spectrum in a certain channel. Does anybody know what the channels are?
6,
Well, that's correct. That's one of the channels, yes.
11,
That's another one, yes.
1.
Yes. These are the different standards I'm going to talk to you about, everywhere from 802.11a to 802.11ah. Now, 802.11a was the second widely accepted standard. It runs anywhere from 1.5 to 54 megabits a second. It's seen worldwide implementation. It's a short range, but it's not very crowded compared to, B or G frequencies. And it uses the orthogonal frequency division multiplexing. It was the first one to do that. Now, who can tell me what frequency 802.11a runs at?
2.4. I don't. Maybe it's 5.
Yes, that's correct. 5 gigahertz is the frequency A runs at. But as I said, it's got a very short range because of the frequency at 5 gigahertz, so it's not near as fast as, or as far as the other frequencies. 802.11b was the first widely accepted standard, and its data rate is only 11 megabits per second. First products on the market appeared in the early 2000s, but it suffers interference from quite a few devices, everything from ovens, baby monitors, cordless telephones. Has anybody ever had this issue? .802.11b was the second standard though. They originally came out with an 802.11 standard. It's legacy now. It was out for about a year and it wasn't very widely accepted. And this was just a reiteration of it. It was done just a little bit better. .802.11g is the third modulation ratified in 2003. It uses off-damp, same as A, and it operates at a maximum physical layer bit rate of 54 megabits or 22 megabits per second average. Now, does anybody know what channel B runs on? Or G, I'm sorry.
Is that by channel? 2, 4, and 5?
2, 4. You're close. Channels, yeah. Does anybody know the different channels on it? 2, 1, 4, 6, and 11. Now, out of curiosity, just to see if anybody knows this, aside from obviously Mr. Hamilton, does anybody know which channels do not overlap? Anybody want to take a guess here?
What?
No.
6.
No. You had one right, but the other one's wrong. There's actually 3 channels that don't overlap here. The answer is 1, 6, and 11. Those are the 3 channels that don't overlap. Now, I don't know if Phil actually finished saying it, but the frequency this operates at is 2.4 is backwards compatible with 802.11b. So any device that runs B can also run on a G device, but it will not run at the full speed of G because it wasn't designed to. Now, the fourth moderation was 802.11n. How many people in this room actually have an N router? Now, it operates at both radio frequencies, 2.4 and 5 gigahertz. So, it operates at a maximum of 54 megabits to about 600 megabits. Now, mind you, that's theoretical. That's very hard to get the full amount there. It was approved in October 2009, and that's MIMO. Who knows what MIMO is? Nobody? It's multiple input, multiple output. It's done via multiple antennas on the device, so it can send and receive. Now this is a new standard. 802.11ac was published in December 2013 and was fully ratified in February 2014. It includes wider channel space from, instead of 40 megahertz, it's up to 80 or 160 megahertz. It's got more spatial streams, which, I don't know if you know what that is. It's the spatial streams are just different channels, basically. Whereas there's like 4 channels for 2.4 gigahertz, there's 8 channels for 802.11ac. The theoretical throughput is 1,300 megabits per second on a gigahertz band. It added multi-user, multiple input, multiple output to make it even faster and better for multiple users rather than, you know, just one user getting multiple inputs and multiple outputs. It happens a lot faster. And as of October 2013, the high-end implementation supported the 80 megahertz channels, but as of right now, they're just now coming out with the 160 megahertz channel devices, which is between this year and next year is when they're going to start coming out with those. Has anybody heard of 802.11ad? It's a new iteration working on the same premise of 802.11ac. It's not fully ratified yet. It's a new physical layer that operates at 60 gigahertz millimeter wavelength. So it doesn't have as high propagation basically. It's very short range, but it will provide a much faster transmission rate. So you're looking at going from, you know, basically 1.3 gigabits a second to 7 gigabits a second. It's got very different propagation. Like I said, it's not near as efficient as some of the other standards. And actually, to take a step back to 802.11n, does anybody know what that's not backwards compatible with? Anybody else? I know you know. Fine. Yep. 802.11n is not actually compatible with 802.11a devices. Now, stepping back to where I was, 802.11ad, the 802.11ad is being produced by, their certification program is being developed by the Wi-Fi Alliance instead of the WiGig Alliance. I don't know if any of you know what that is. But the brand names they're looking at putting on them, as you can see, is WiGig. It's what they're going to start branding them as. .802.11af. Anybody heard of this? It's also referred to as Wi-Fi or Super Wi-Fi. It's an amendment approved in February 2014 that allows wireless LAN operation in TV white space spectrum. So This operates in TV channel spectrums to allow much greater propagation. They actually determine the access point location via GPS satellite. So, and it uses the internet to query, geolocation provided by a regional regulatory agency to discover what frequency channels are available. So you probably won't be setting it up. More than likely, it'll be setting itself up. The physical layer still uses off-DIM based on 802.11ac. So, and propagation, path loss, as well as the attenuation by materials such as broken concrete is much lower than the rest of the standards. So it'll be able to travel much farther distances. It's also capable of using multiple user operations, same as 802.11ac. But it operates on a 4-stream instead of an 8. So no big channel spacings. And the data rate achievable with this, though, is for the 6 and 7 megahertz channels is about 26.7 megabits a second. And for the 8 megahertz channels, it's about 35.6. And if you bonded all of the streams for 6 and 7 megahertz, you're looking at about 426.7 megabits a second. And for the 8 megahertz channels, you're looking at 568.9 megahertz a second, or megabits a second. I don't know about you, but that sounds quite nice.
Yeah.
And another one is 802.11ah. Has anybody heard of this also? No? This one actually isn't even out yet. This is slated to come out in March 2016. The 802.11ah defines basically a wireless operating at sub 1 gigahertz license exempt bands. Like I said, final approval for it's March 2016. It's got very favorable propagation characteristics with low frequency spectra. It can improve transmission range. It also operates at the 2.4 and 5 gigahertz channels. So it's backwards compatible. Obviously not with A, but it would be backwards compatible with probably BG and N devices. It's supposed to be used for various large-scale sensor networks, such as cellular networks, extended hotspots, cellular offloading. But as I said, the bandwidth is relatively narrow. Does anybody have any questions?